AI model versioning and rollback strategies, how senior engineers manage model lifecycle in production. Welcome back to Agentic AI World. I'm your host, and today we're tackling a topic that separates junior AI engineers from true production veterans: model versioning and rollback strategies. If you've ever shipped a new model to production and watched metrics crash within an hour, this episode is for you. Let's set the stage. You've trained a new model. Offline evals look great. You deploy it. Then 3 hours later, your customer success team is getting flooded with complaints. What do? If your answer is panic, you need model versioning and rollback built into your system from day one. Why model versioning is non-negotiable? Unlike traditional software, AI models have a unique failure mode. They can degrade silently. A bug in code usually throws an exception. A degraded model just gives slightly worse answers. Users notice before your dashboards do. Senior engineers treat every model as a versioned artifact, just like software releases. Each model version gets a unique identifier, a set of metadata, and a clear lineage. What data was it trained on? What hyperparameters? What evaluation scores? And who approved it for production? The key insight is, you're not just versioning weights. You're versioning the entire inference contract. The model, its prompt templates, its pre-processing logic, its output schema. Change any one of those, and you have a new version. The model registry pattern. Every serious AI team runs a model registry. Think of it as your model's source of truth. Popular options include MLflow, Weights and Biases, SageMaker Model Registry, and Vertex AI Model Registry. Here's what every registry entry should contain. A unique version tag. Semantic versioning works well, like version 2.3.1. The artifact location, S3, GCS, or a dedicated model store. Training metadata, dataset version, training run ID, hardware used. Evaluation results, your key metrics, broken down by segment. Deployment status, staging, Canary, production, archived. Approval audit trail, who signed off and when. Without a registry, you're flying blind. You can't roll back to something you can't find. Deployment patterns for safe rollouts. The most important thing you can do is never do a hard cutover. There are 3 deployment patterns every AI engineer should know cold. Pattern 1, shadow mode. Your new model runs in parallel with the current model. It receives all the same requests, but its outputs are logged, not returned to users. You compare old versus new on real traffic. No user impact. Pure signal. Pattern 2, Canary deployment. You route a small percentage of traffic, say 5%, to the new model. You monitor closely. If metrics hold, you gradually increase the slice. 10%, 25, 50, then full rollout. This is the gold standard for production AI deployments. Pattern 3, blue-green deployment. You maintain 2 full production environments. Blue is live. Green has the new model. You switch traffic in one atomic operation. If something goes wrong, you flip back instantly. The cost is maintaining double infrastructure, but for high-stakes systems it's worth it. Defining your rollback triggers. A rollback strategy is only as good as its trigger conditions. You need to define these before you deploy, not after things go wrong. Common automated rollback triggers. Error rate spikes above a threshold, say, more than 2% of requests returning errors. Latency P99 exceeds your SLA by more than 20%. Safety classifier flags a spike in harmful outputs. Business metric degradation, click-through rate, conversion, user satisfaction scores drop more than 5%.